Hello, in this video, I will explain to you on how to solve this problem. Consider the circuit shown below. Find I1, I2, I3, I4, and I5. So basically all the current in the circuit. And then B, find the power supplied by the voltage sources. And C, find the power dissipated by all the resistors. Okay. And I think we need to label some loops and currents in this circuit here. And what I'm gonna do is first label the polarity of the resistor. It will be very helpful later. So where the current comes from is the positive terminal. And where the current goes to is the negative terminal. See it here because this I1 will pass through this resistor like this, right? And let's do that for all the resistor. So R2 here, I2 will flowing to the left like this. So this one will be positive and this one will be negative. And I3 will go pass through this resistor like this. And this one is positive where the current comes from. And where the current goes to is negative like that. And this also the same, right? So we will have I4 flowing down. And this one will be positive terminal. And this one will be negative terminal. Good. And then what else? I will name this point here or this node as node A. And then this node here as node B. We will use junction rule at node A and node B. But we will do it later. But what I want to do is draw all the loops in the circuit. So here, I will have the first loop here as loop 1, like this. And then loop 2, like this. And then loop 3, like this. So we have 3 loops in this circuit. And I want to start with loop 3. Why? Because we have all the unknowns here. And we can find out the first current here, I4, right? So let's start with the loop rule at loop 3. Loop rule at loop 3. Okay, and the loop rule said that the sum of the voltage in a loop will equal to 0. However, remember that voltage is equal to the current times resistance. Good. Okay, now let's see here. Let's start with this 5-volt battery and the loop here entering from the negative terminal. So we will have negative sign. So I have minus. And then the voltage is V2. Good. And then it will enter this resistor here from the positive terminal. So we will have positive sign here plus. And then the voltage is current times resistance, and the current is I4, and then the resistance is R4. Okay, and that will equal to 0 because there are only 2 components in this loop, right? Now we can just plug in the values. V2 is 5 volts, so I will have minus 5, and then I4 is what we are looking for, so we'll have I4 here. And then what else? I think we will have R4 here, which is 2 ohm. So I have this is equal to 2, and that will equal to 0. Or we can manipulate this for 2I4 is equal to 5, and therefore I4 here is 2.5. And the unit here will be in ampere. And I think we have our first value here. I4 is 2.5 ampere. Good. Okay, now what can we do from here? I think I will start with this loop here. No, this point here. So I will use the junction rule at point A. So we have junction rule at point A. And what does the junction rule say? The sum of the current that goes in will equal to the sum of the current that goes out. What is the current that goes into point A? We will have I3 and I1, right? So we will have I1 plus I3, and that will equal to I2, right? Because I2 going there. And so we will have I1 here is equal to I2 minus I3. And I think nothing that we can do from here. Now let's do the loop rule at loop 1 and loop 2. Okay, now let's do that. Loop rule at loop 1. Loop rule said that the sum of the voltage in a loop will equal to 0. Good. Let's start from this battery here. So I will have minus here because the loop is entering from negative terminal. Okay, we will have minus, and then the voltage will be V1. Good. And then the loop here entering from the positive terminal. And so we will have the voltage here is equal to the current times resistance, and that will be I1 multiplied by R1. Good. And then the loop here will enter into this R2 here from the positive terminal. So we will have plus, the current is I2 and the resistance is R2. And all of that will equal to 0. Okay, now let's plug in the numerical values. So we'll have minus 12 and then plus I1 is unknown, but R1 is 4 ohm. So I'll have 4 I1. And then we will have plus I2 is unknown, but R2 is 3 ohm. So I will have 3 I2. And all of that will equal to 0. Now let's plug in this. I1 is equal to I2 minus I3. So we will have 4 I2 minus I3. And then plus 3 I2. And that will equal to 12. Good. 4 times I2 is 4 I2 and then plus 3 I2. So I will have 7 I2 here. And then 4 times minus I3, that will be minus 4 I3. And that will equal to 12. Okay, I think nothing that we can do from here. Let's save this as equation number 1. Now let's do another loop rule, but this time at loop 2. Okay, let's clean this up. Okay, now let's do the loop rule at loop number 2. Loop rule at loop 2. And again, we have the sum of the voltage in a loop will equal to 0. Let's start from this battery here, and the loop is entering from the positive terminal, so we will have positive 1, so I'll have V2. And then let's move on to this resistor here, R3, and the loop is entering from the positive terminal. So we will have plus, and the current is I3, and then multiplied by R3. Good. And then the last component here is R1, and the loop entering from the negative terminal. So I will have minus here. Minus, and then we will have I1 multiplied by R1. All of that will equal to 0. Okay. And then what is V2? I will have 5. And then plus R3. R3 is 2 ohm. So I will have 2I3. And then minus I1 times R1. R1 is 4 ohm. So I will have 4 I1. Good. All of that will equal to 0. And now let's plug this equation. I1 is I2 minus I3 to here. So we will have 2I3 here. And then minus 4. And then multiplied by I2 minus I3. And that will equal to minus 5. Good. So now we will have 2I3 minus 4I2 and then plus 4I3, and that will equal to minus 5. And so we will have minus 4I2 and then plus 6I3, and that will equal to minus 5. Okay, now we have equation number 2. And we need to solve equation number 1 and number 2. Okay, let's clean this up first. Okay, now we need to solve for 1 and 2. Solve 1 and 2 to get I2 and I3. And I will use calculator to do that, because it is the fastest way to solve an equation. So let's set this up. Equation solver is number 5. Two variables is number 1. And let's plug in the coefficient. So we'll have 7. And then minus 4. And that will equal to 12. Okay, and then we will have minus 4. And then 6. And then minus 5. So here I will have I2 is equal to 2 ampere, right? So X value is I2, and that will be 2 ampere. And then what is I3? I3 is the Y value here. So we will have 1 over 2, or 0.5 ampere. So I have 0.5 ampere. And that is also important values for this problem, because now we have I2 and I3. But from here, we can calculate I1. I1 is I2 minus I3. So here we will have I1 is equal to 2 minus 0.5. Therefore, from here, I1 is 1.5 ampere, right? So let's write it here. So we'll have I1 is equal to 1.5 ampere. 1.5 ampere. Okay, we have I1, I2, I3, and I4. And here we can also calculate I5 from the junction rule at point B. So we'll have junction rule at point B. Okay, and the junction rule said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And the only current that goes in is I4. So we'll have I4 here. But then that will equal to I3 plus I5, because both are going out. So I have I3 plus I5. However, we have I4 is 2.5. And then I3 is 0.5. So I have 0.5 here plus I5. And from here, we know that I5 is equal to 2 ampere. And we have found all the currents here, I1, I2, I3, I4, and I5. So let's highlight all of them. I1, I2, I3, I4, and I5. Okay, so we have all the values, and that is the answer for question A. And then let's move on to question B and C. Okay, let's save all the currents and clear this up. Okay, now let's move on to question B. Find the power supplied by the voltage sources. Okay, so remember that power is just the voltage multiplied by the current. And we have two voltage source, right? This one, V1 and V2. So the total power supplied by the voltage sources is the first one, V1, and the current that passed through this battery here is I2, right? Because I2 flows here and eventually flows there. So I'll have V1 multiplied by I2, and then plus here I will have V2, okay, and the current that passed through it is I5. So I'll have I5. And we can just plug in the number. So we will have V1 is 12 volt. And then I2 is 2 ampere. And then we will have V2, which is 5. And then I5 is 2. So we'll have this one here. So we will have 24 plus 10. And that will be 34. And the unit here is watt. And then for question C, find the power dissipated by the resistor. And for this problem, I will use this formula here. P is I squared multiplied by R. And we have 4 resistor here. So let's do that. So we will have P total here. Let's start with R1 here. And the current that pass through it is I1. So I will have I1 squared multiplied by R1. And then for R2, we will have this one here, and the current that pass through it is I2. So I have I2 squared multiplied by R2. And then for I3 is here, and I will have I3 squared multiplied by R3. And then I4 squared multiplied by R4. Okay, so now we have I1. I1 is 1.5. So 1.5 squared multiplied by R1. R1 is 4. So have this. And then I2. I2 is 2. So 2 squared multiplied by R2. R2 is 3. So I have 3 here. And then plus I3. I3 is 0.5. So I have 0.5 squared multiplied by R3. R3 is 2. And then I4 is 2.5. Okay, so I have 2.5 squared. And then R4. R4 is 2. And I think the fastest way to calculate this is using calculator, right? So let's set this up as computation. So we'll have 1.5 squared multiplied by 4. And then 2 squared multiplied by 3. Then plus 0.5 squared multiplied by 2. And then plus 2.5 squared multiplied by 2. And we will have 34, which is the power dissipated by the resistor, which is perfectly makes sense because the power supplied and the power dissipated is the same. And I think that's all for this problem. Very long problem, but I think that is correct from here. And then thank you for watching. Please leave me a comment if you spot any mistakes during my calculation. And then do not forget to like the video, subscribe to the channel, and then once more, thank you for watching and see you in the next video. Bye bye.